On behalf of Rohini College of Engineering and Technology, myself, Justin Leo, Assistant Professor of Department of Mechanical Engineering, I welcome you all for this Maintenance Engineering course. And the course code is ME6012. This is an elective course for the mechanical engineering students of Regulation 2013. And in this video session, we'll be studying about methods of condition monitoring of Unit 3. So the main objective of studying this course is to enable the student to understand the principles, functions, and the practices adopted in industry for the successful management of maintenance activities, and to explain the different maintenance categories like preventive maintenance, condition monitoring, and repair to machine elements, and to illustrate some of the simple instruments used for condition monitoring in industry. So these are all the syllabus for the third unit, condition monitoring, cost comparison with and without condition monitoring, on-load testing and off-load testing methods, and the instruments and methods for condition monitoring, like temperature sensitive tapes, pistol thermometers, and wear debris analysis, etc. So these are all the textbooks and reference books for this maintenance engineering course for the students. And coming to the course outcomes, the students will be able to apply the concept and principle of maintenance processes based on the industrial configuration upon completion of Unit 1. And the students will be able to analyze the maintenance categories, preventive maintenance, methods of lubrication, and TPM upon completion of Unit 2. And the students will be able to illustrate appropriate condition monitoring techniques, including vibration, thermal, and lubricant analysis upon completion of Unit 3. And upon completion of Unit 4, the students will be able to analyze the various repair methods for basic machine elements. And upon completion of Unit 5, the students will be able to analyze the various repair methods for material handling equipments. So introduction to condition monitoring. This condition-based maintenance, that is also called as predictive maintenance, it is nothing but a technology that strives to identify incipient faults before they become critical, which enables more accurate planning. So planning is very, very important for this condition-based maintenance. And it is a set of maintenance action which is based on a real-time or a near real-time assessment of the equipment condition, which may be obtained by various sensors. And it allows maintenance to be scheduled or other actions to be taken to avoid the consequences of failure. And condition-based monitoring is a means of improving productivity, product quality, overall effectiveness of manufacturing, and availability of process machinery. So methods of condition monitoring. So condition monitoring is the process of monitoring a parameter of condition in machinery so that a significant change is indicative of a developing failure. So these are all the methods of condition monitoring. So first one is the visual monitoring, vibration monitoring, temperature monitoring, lubricant monitoring, leak detection, noise monitoring, and corrosion monitoring. So what is visual monitoring? It involves inspection and recording of surface appearance. So you can use boroscope to see inaccessible places, and the use of photography or surface imprinting for record purposes. So this is what the visual monitoring is, and you can see from this diagram, this figure. So they are using some aided equipments to assess the parts which are not visible directly by the naked eye. And this method of condition monitoring, second method is vibration monitoring. So this is nothing but which involves attachment of a transducer, that is a velocity probe, accelerometer or a proximeter probe to a machine to record its vibration levels. So here the concerned person is placing a probe over the machine, and the vibration level has been indicated here. And the special equipment is also available for using this output from the sensor to indicate the nature of vibration problem and even its precise case. So next one is the temperature monitoring method. So the temperature monitoring sensitive aspect of a unit can be readily monitored. So these includes contact thermometers, thermocouple, thermistor, and temperature chalks and paints and infrared detectors. So these are all the temperature monitoring equipments which are used for monitoring the condition of the equipments. And the next method is the lubricant monitoring. So here the use of magnetic drain plugs in unit lubrication sump is well known, and the existence of magnetic debris would give the information on the surface condition of the load bearing parts. So that you can identify the condition of the equipment. And the next method is the leak detection. So here you have a number of detecting techniques, including soap and water methods, and the use of proprietary preparation can make this method more effective. And here you can use this ultrasonic detection, which is very powerful techniques for detecting this leak detection. And the next method is the corrosion monitoring. So it is usually applied to a fixed plant containing aggressive materials, and which is intended to monitor the rates of internal corrosion of the walls of the plant. So normally this may be done by drilling sensation of holes part way through the wall, which can be plugged when they leak, or by inserting readily removable coupons of materials, which the corrosion rate is assumed to relate to that of the plant. And the final condition monitoring method is the wear debris monitoring. See, this normally works on the principle that a working surface of a machine are washed away by the lubricating oil, and any damage to them can be detected from the particles of wear debris in the oil. So if the debris consists of relatively large lumps of ferrous, such as those generated by the fatigue of rolling element, bearings and gears, or the pitting of cams and tappets, these can be picked by the removable magnetic plugs inserted in the oil return lines. And for smaller debris particle, you can use this spectrographic analysis or microscopic examination of oil samples after magnetic separations, or commonly used techniques. So this is how this wear debris monitoring is carried out. And coming to the advantages of condition monitoring, you do have this studies have estimated that proper function of predictive maintenance program can be provide a savings of 8 to 12% for that of the preventive maintenance program alone. And also independent surveys indicate the following industrial average savings, that is maintenance cost is being reduced from 25 to 30%, and breakdowns are eliminated from 70% to 75%, and process downtime or equipment reduction in equipment is from 35 to 45%, and the production rate is increased from 20% to 25%, and the operational life and availability of the increased component allows primitive corrective actions, and the cost of parts and labor are decreased, product quality is better, and worker safety and environment or both, or environmental safety of the workers is improved. So coming to the disadvantages of condition monitoring, Diagnostic equipment is being costly has increased the investment, and even the staff training increased the investment, and the management cannot see readily potential savings because of this condition monitoring, because the more cost is involved here. And applications of condition monitoring normally used in detecting the malfunctioning, component detection of component failure, and assessing the formalized techniques. And this condition-based monitoring process can be applied to maintain activities in all industries, including weapon systems, jet engines, wind turbine generators, marine diesel engines, natural gas compression, circuit card manufacturing, etc. So with this, we come to an end with this video session of methods of condition monitoring. So thank you and have a great day.